All right, so we are going to talk about putting things into scientific notation and putting things into standard form. So standard form is when you see regular numbers. Scientific notation is just what we use when we want to talk about very large numbers or very small numbers. Very large numbers are going to have positive exponents. So what you have to keep in mind is that we're gonna have a number in front, and then it's gonna say times 10 to some power up there. This number up front needs to be between 1 and 10. If it's any bigger or smaller, it's not in proper scientific notation. So we have to first figure out where is our decimal. Where does our decimal start when we're looking at numbers? Okay, so my decimal's here. Where can I move it to so it falls between 1 and 10? Well, if I put it out front here, then it's 0.34. So that's not right. If I put it here, then it's 34, which is over 10. So it's got to go right in the middle where that comma is. So then my answer is 3.4 times 10 to some exponent. That exponent comes from how many times did we move the decimal place? Well, my decimal place started here, so I moved it 1, 2, 3, 4, 5, 6 times. So if I move my decimal 6 times, then it's to the power of 6. Okay, so let's just kind of go over that again. We have to figure out where our decimal goes. So it starts here. Where does it go? It's got to be between 1 and 10. If it goes all the way in the front, it's 0.82, which is less than 1. If it goes after the numbers, then it's 82, which is over 10. So it's got to go right in between these two numbers. So I know my answer is 8.2. We have the rest of the flow here times 10 to some exponent. We have to count 1, 2, 3, 4. And it's a positive 4 because it's a large number. Okay. So now we're going to represent very small numbers. Very small numbers get negative exponents. Okay. So small numbers get negative exponents. So again, it's something times 10 to some power. The number still needs to be between 1 and 10. So we're given our decimal places. Now we need to figure out where to put it. If we put it all the way at the end here, then my number is 921, which again is too small. So if I put it, I'd have to put it right here between the 9 and the 2. So then we have to figure out, well, how many times did I move the decimal? Well, if it's between the 9 and the 2, I move my decimal 1, 2, 3, 4, 5, 6, 7 times. So my answer is 9.21 times 10. And instead of just 7, we're going to make it -7. Okay, can you try this last one for me right there? Try that last one. So in this case, we do want to move it all the way to the end there. So it's 7 times 10 to the 1, 2, 3, 4, -4. Okay. Sometimes we said they're not in correct scientific notation. That typically means the front number does not fall between 1 and 10. So if we're changing this 93.5, we're taking a bigger number and making it smaller. So if we're taking a bigger number, we're going to add 1. So this is 9.35 times 10 to the 7th. So if I move it to the left, I add 1. If I move it to the right, I'm making a small number bigger. I'm going to subtract 1. So it's 6.4 times 10 to the 7th, right? When it was a big number, we had positive exponents, so that's why we added. We had small numbers, we had negatives, so it's -1, which makes it 7. All right, now we're gonna put them into, oh, we're still talking about scientific notation, sorry. Sometimes we can approximate, so that means round to a single digit. So I'm just gonna look at these two numbers because I want to round it to one number. What would I round 32 to? Would I round it up to 40 or would I round it down to 30? Well, I would round this down, so it's gonna be 3 times 10. I want to move my decimal from here all the way over there because I want it rounded to one digit. So then count how many times we move it. Hopefully you got that we moved it 8 times. Looking again at the first two numbers, we are going to round, what would I round 97 to? Would I round that down to 90 or would I round it up to 10? I would round it up, right? So this one's tricky. This is really going to become a 1. And this is going to be a 0, and that's going to be a 0 because we're rounding it up. So we now want to move my decimal place here. So it's going to be 1 times 10 because we said 9.7 would round up to 10. So it's rounding up to 1. And we're moving the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And because it's a small number, it's a negative exponent. Okay. Now we're gonna make it standard form. So if it's a positive exponent, we move to the right. If it's negative, we move to the left. Okay. And that's because when it's positive, it becomes a big number, right? So if it's positive, it becomes a really big number. If it's a negative exponent, it becomes a small number. So we're going to take the 7.1, and now we're going to move it however many times it said. In this case, 5. So I'm going to move it 1, 2, 3, 4, 5. There's no numbers here, so I'm going to put zeros there. So now my answer is 710,000. If it's negative, like this one is, I'm going to move it to the left. Kind of shows you which way to move it, right? Negative sign points to the left. So I'm going to move it to the left 4 times. So 1, 2, 3, 4. Put a decimal place, put some zeros there. So it's 0.30802. Try this last one on your own for me. Try that last one on your own. Hopefully you got 0.013. You only move it twice. It's negative. You move to the left because we want it to be a tiny decimal. Sometimes your calculator can't show, depending on what calculator. If you're using those little blue ones, they don't have enough numbers to show. And sometimes your phone calculator will show, instead of like how our formula is times 10 to some number, just another way to write that is using the letter E or double E's. So really, this is saying we want to take 5.44 times 10 to the 8th power. So that's what the EE means. The EE just means times 10. Oh God. So that's all it means. It just means the times 10. Okay. So then let's write that using a different format. So we want to write that in standard form. So we're going to move it 8 times, which means 1, 2, 3, 4, 5, 6, 7, 8. So add lots of zeros. So you should have 544 million. Okay, so try this one. Figure out how you would write it using scientific notation and then put it into standard form. So do both. So take a moment and pause and try this last one. Okay, so hopefully you did 7.18 times 10 to the negative 7th. And that means you move it 7 times. So you should have 0.6 zeros, 718. Okay, those are the notes.